Hello everyone and welcome to the tutorial series brought to you by Walchand College of Engineering, Sangli and Electronics Engineering Student Association, ELISA. Today we are going to learn about 7-segment display and how to interface it with 8051 microcontroller in static mode. Alright, let's get started then. Knowledge about how to interface a 7-segment display to a microcontroller is very essential in designing embedded systems. As you can see, a 7-segment display consists of 7 LEDs arranged in the form of a squarish 8 slightly inclined to the right and a single LED as the dot character. Different characters can be displayed by selectively glowing the required LED segment. 7-segment displays are of two types, common anode and common cathode. The common cathode is active high type and common anode is of active low type. To understand the concept of active high and active low, let's have a look at the LED arrangement. In common cathode type, the cathode of all LEDs are tied together to a single terminal which is usually labeled to as COM. And the anode of all LEDs are left alone as the individual pins labeled as A, B, C, D, E, F, G and DP for the dot, as shown in the diagram. Similarly, in common anode, the anode of all LEDs are tied together as a single terminal and cathodes are left alone as individual pins. Now let's have a look at the digit drive pattern of the 7-segment display. The configuration used to find this hex code is common anode type. Therefore, in order for an LED to glow, we give it a 0, that is active low configuration. Each segment requires a current of 20 mA. With all segments on, the current drawn by one 7-segment display would be 140 mA. I would like you to go ahead and find if these hex codes are in fact the correct ones. It would be a good exercise for you. Now that we have enough knowledge about 7-segment LED display, let's move on to the actual interfacing. This is the circuit diagram of the interfacing. As you can see, port 2 of the microcontroller is used to send data to turn on off the individual LEDs. The port pins turn the individual LED bits A to G and DP on off according to the program uploaded in it. Now I'll just click the run button and let's see what the output looks like. The program fetches the data accordingly and displays the output on 7-segment. The program which I uploaded is that of a decimal counter. Therefore, the display shows output from 0 to 9 and then repeats it. Let's have a look at the program uploaded in the 8051 now. The array name real digit contains the hex codes for digits 0 to 9. It is worth noting that I have used common cathode type configuration, that is active high. The main function displays the digits one after another with a delay of 500 milliseconds. Now as this is a decimal counter, I have iterated the for loops 10 times only. You may iterate it till the length of your array. A point to note is that I have put all this code inside a while loop, which is always true. It is because of this loop that the program runs continuously. Add this file to your project and build it, but don't forget to create a hex file first. In case you don't know how to create one, here's the procedure. Right click on the target one, click on the options, go to the output block and check the create hex file checkbox. Then click OK. Now when you build this code, the hex file will be automatically created and saved where your project is located. After creating your hex file, go to the Proteus simulation, right click on the 8051 object, edit properties, and then program file, browse the hex file. In my case it's sex7.hex and just open it. This automatically uploads your code in this 8051 and it delivers the output accordingly. Now that we are done with this simulation, there is one thing worth noting. All of this works perfectly in a simulation, but in real life, there is a major concern of overcurrent, which would never happen in case of a simulation, obviously. Although a 7-segment display can be thought of as a single display, It is still 7 individual LEDs within a single package, and as such, these LEDs need protection from overcurrent. LEDs produce light only when it is forward biased, with the amount of light emitted being proportional to the forward current. This means that an LED light intensity increases in an approximately linear manner with an increasing current. So this forward current must be controlled and limited to a safe value by an external resistor to prevent damage to the LED segments. For that purpose, we attach external resistors typically of a value of 220 ohm. With this, we are almost done with the interfacing of 7-segment display. But wait, what if we had to design a 2 or 3 or even a 4-digit counter? In that case, we would have to connect a second 7-segment display to another port of the microcontroller. Pretty simple, right? But again, what if we had to make a 5-digit counter? As we have only 4 ports, we would run out of pins to connect. Also, if you recall, at the beginning of this video, I told you that one 7-segment takes up to 140 milliampere. That means 4 7-segment would take up to 560 milliampere. This is where the concept of dynamic display comes in picture. We would be learning about dynamic display in detail in the next video. Thank you.